Hey there, today's video is going to be about this algebra toolbox of some techniques that are going to help you solve math questions in physics. Now, in physics, it's important to note that we don't actually care too much about the final numerical answer to any given question. Instead, what we really care about is the general solution to that problem. And then once we have that, we can just plug in numerical values to get that final numerical answer. So most of the time you spend solving physics questions is going to be about translating a physical system into the language of mathematics and then manipulating those mathematical equations to get that general solution. And then you can just plug in the numbers with your calculator. So I'm going to get started by looking at addition, subtraction, multiplication, and division. And I have some more resources available for you on my website, which is learning.withgideon.com. All right, let's get started by looking at how we can add, subtract, multiply, and divide to help simplify and solve equations. Now, the idea is you're going to be able to add, subtract, multiply, and divide the same value to both sides of an equation. Okay, let's give a sample equation here. Let's say we have 12a is equal to 8b. And one way to think about this is to say that the price of 12 apples is equal to the price of 8 bananas. Okay, so when we think about it this way, we can see that the equation 12a is equal to 8b. This is actually kind of like a balance, right? It's like we have the price of 12 apples on this side and the price of 8 bananas on this side, and they are both equal. So if we wanted to put them onto a balance, it would balance, right? When you think about it this way, you can see how adding, subtracting, multiplying, or dividing the same value to both sides will wind up maintaining this balance. And so we will wind up with a valid equation, right? So if the price of 12 apples is equal to the price of 8 bananas, then that also means the price of 12 apples plus $5 is equal to the price of 8 bananas plus $5, right? So if we add $5 to both sides, you still have the same balance. Likewise, you could subtract $10 from both sides, and it would still maintain balance. You could multiply by 2 to both sides, and it would again maintain that balance. And so this equation is always valid if you're doing this operation, the same operation to both sides here. So as an example, why don't we divide both sides by 4? Right, and if we do that, what happens? Well, we're going to get 3a is equal to 2b, right? And so doing this has helped us simplify the equation. We've reduced this 12 and 8 into a 3 and a 2, and it's a little bit easier to think about this way. So that's a very simple way of simplifying things. And if we wanted to, we could go further. We could divide both sides, say, by 3, in which case this would cancel out, and we would be left with a is equal to 2/3 b, right? So here we have a more simple way of writing down this initial equation right here. These are equivalent. These two equations are equivalent, but I think you would agree that this is a little bit more simple, right? So this is how we can use addition, subtraction, multiplication, and division, and adding these values to both sides to simplify an equation. This is very useful in physics. Next, we'll take a look at a more advanced way of multiplying both sides by the same value when we cross multiply fractions. All right, so what do we mean by this? Well, let me give you an example of some fractions here. Let's say we have a over 4 is equal to b over 3. Well, sometimes fractions can be annoying. We don't always like to have fractions. And so we want to find a new way to rewrite this equation that gets rid of the fractions. And the way we do that is, well, the long way to do that would be to take this initial value and maybe multiply both sides by 4, right? So if you do that, these 4s will cancel, and so you've gotten rid of the fraction on the left-hand side here. We're left with a is equal to 4b over 3. So we're halfway done. We still have one fraction left, and I'm sure you can see if we simply multiply both sides by 3, then these will cancel, and we'll be left with 3a equals 4b. So we've successfully translated this initial equation with 2 fractions into an equation with 0 fractions. And I kind of prefer 0 fractions most of the time. We could even, if you wanted to simplify this further, and say this is a equals 4/3 b, right? And so this maybe even looks even more simple. Now, if we rewrite this, we can see that we followed a certain pattern here that we call cross multiplication. What we've done is, to get rid of these denominators, we take this denominator and multiply it across to this numerator, and we take this denominator and multiply it across to this numerator. And if we do that, you can see we very quickly get 3a is equal to 4b. So we have successfully reproduced the answer here using this kind of shortcut that we call cross multiplication. Okay, so that's another handy thing to do there. Okay, the next little technique we'll look at is distributing. Okay, so distributing is kind of a shortcut way of writing down multiplication. Here's a sample equation. We've got 8a plus 5 is equal to 4 times the quantity of 2b plus 1/2. Okay, so what we can do is we can distribute this value here by multiplying it into all of the values in the parentheses. So we're going to wind up getting 2 times 8a is 16a, 2 times 5 is 10, right? And we do the same thing on here, and we multiply the 4 into there and into there, giving us 8b plus 2. Okay, now at this point, we can try and simplify this further. Maybe we can subtract 2 from both sides, right, to get rid of this 2 here. And we'll wind up with 16a plus 8 equals 8b. And I think we can see that we can divide everything by 8. And this will give us 2a plus 1 equals b. So we've simplified this big equation and gotten this here as a final equivalent result. Much easier to look at and to see what's happening there. So next we'll look at factoring. You can think of factoring as sort of the inverse of distribution, right? So instead of distributing a number into something, you're going to be taking a factor out of something. So for example, if you have a simple number like 64a plus 16, right? You can rewrite this as 8 times 8a plus 2, right? So you factored out an 8, and these two sides are the same, right? So going this way, it's factoring, but going this way, it's distributing, right? So you can sort of see how factoring is the inverse of distributing. Now in physics, this often becomes useful if you have equations with lots of variables in there and constants. So for example, let me give you a made-up equation. Let's say we have mv times mu plus mv times k. Okay, now how could we rewrite this? Well, we can factor out an mv, right? An mv, and we would be left with mu plus k. Now, this can actually be kind of useful because this mv, you might recognize, is momentum, mass times velocity, right? So what this is sort of saying is that you have that total value here is equal to the momentum of something multiplied by mu plus k, which are often constants, right? So it's sort of the momentum times the sum of these two constants gives you this final result. And that's a better way of thinking of it than the momentum times mu plus the momentum times k. Here's just the momentum times this sum, right? And so as in a physical system, factoring is often useful to take important things out, factor them out, and it helps you think about the system and understand it a little bit better. All right, let's look at one final manipulation here. And that's something that we often do, and that's going to be combining like terms. Okay, very common thing when solving physics equations. The idea behind this is very simple. If you have 2a and you add in 3a, well, we can say that that is the same as 5a, right? So we're combining all of the a's together. Sometimes you might have some crazy big expression like 10 times q epsilon naught pi r squared minus 8 q epsilon naught pi r squared. And this looks very big, and you can have lots and lots of these, but we can combine these like terms because you can see that this section and this section here, the q epsilon naught pi r squared, you can sort of treat them as a single term. And so we can simplify this into 2q epsilon naught pi r squared. These are equivalent, and this is something that will happen very frequently when solving physics questions. Let's do one more example just to drive this point home on how we combine like terms. So we have b times the quantity 2a plus 3, and then plus 6a is equal to a times the quantity 5b plus 7, and then that plus 4b. Okay. Let's try and solve this real fast. Well, we see we can distribute this b in here. We can distribute this a into here. So let's do that. We'll wind up with 2ab plus 3b plus 6a is equal to 5ab plus 7a plus 4b. Okay, so after that step, we arrive here and we want to combine the like terms. Okay, so let's do that. We could start out by subtracting 2ab from both sides, right? So this will cancel here. And then we could subtract 3b from both sides, and this will cancel here. And then we could subtract 6a from both sides, and this will cancel here. So what we wind up with is 0 on the left-hand side is equal to 3ab plus a plus b. And that's going to be a much more simple way of writing down this initial big mess of an equation there. So combining like terms can often help you simplify equations greatly. Okay, so just to recap really quickly, we saw how we could add, subtract, multiply, and divide the same value to both sides of an equation. And what that does is it's going to maintain balance. Both sides will still be equivalent to each other, and sometimes that can help simplify your equation. So for example, if we have an equation says that 5a is equal to 2b, then what we could do is we could add y to both sides, and this would still be correct. Or we could subtract y to both sides, or multiply y to both sides, or divide y to both sides. And this general form would still maintain its balance. It would still be correct and true. So that's the first way we looked at to help simplify and manipulate equations. The next was a way to get rid of fractions. We don't like fractions, usually, sometimes. To do that, we're going to cross multiply fractions, and that's going to help us get rid of them, which is sometimes useful. And the general form here would be, if you have a fraction a over b is equal to c over d, then what we can do is we can cross multiply the denominator to the numerator across the equal sign, and we wind up with AD is equal to BC, right? No more fractions. Makes me happy. The next thing we looked at was distributing and factoring equations, right? These are sort of inverses of each other. So if you start out with something like A times the quantity of B plus C, you can distribute that A through, and we'll wind up with AB plus AC. Likewise, if you start out with this and go back to here, factor out the A, you'll get that initial part, right? So distributing is going to the right and factoring is going to the left here. So they're sort of inverses of each other. And the final manipulation we looked at was combining like terms. And this is a very simple way of tidying things up to get rid of many extraneous terms there to make things simpler. So for example, if you had something like 5a plus 2a minus 6b plus 2b, well, we could very easily combine these terms together, and we'll get 7a minus 4b, right? So a simpler way of writing this down. All of these manipulations are fairly simple, but they're also very common when solving physics equations. So I wanted to put this out there for you, and I'm going to have some more videos on other ways of manipulating and solving equations. I've also got a little cheat sheet on my website that you can go to take a look at even more algebraic manipulations that are very useful to just sort of have handy.